Hey, and welcome to our next unit, all about pollution, specifically air pollution. So, we are going to dive in to the wonderful world of breathing in the disgusting, nasty stuff that is out there in the air. Well, guess what? With this social distancing and all the bans on travel and the lack of driving around and the lack of airplane travel, our air is getting a lot cleaner. So, that's a good thing. But let's take a step back and imagine if we weren't in this case, what would be going on? So today we are going to cover slides 1. Let me take this down. That way you guys can kind of see this. Slides 1 all the way through 12. And we're going to introduce air pollution to you guys and get ready to start the fun. So without further ado, let me bring you to air pollution. All right, air pollution is everything in the atmosphere, everything that we breathe, the troposphere, the mesosphere, the ozone layer, the stratosphere, all of that wonderful stuff. And how it gets there and where it comes from. Is it naturally occurring? Is it anthropogenically occurring, man-made? So let's dive right on in. Health effects of air pollution. So what you're looking at there is a healthy lung and a non-healthy lung. This is a black lung, right? A lot of the coal miners would get this because they're constantly breathing in that particulate matter, all right? And essentially it kills your lungs. So normal lungs on the left and the lungs of a person who died from emphysema on the right. You could see how it has just totally ravished the lung and completely engulfed it and just like suffocated it and did a horrible thing to this lung. And as you know, lungs are required for our breathing. So if you take out the lungs, you take out the breathing. So moving on, air pollution. What is air pollution? They are gases, they are liquids, they are solids in the atmosphere. Anything that is in the air that we are breathing. It's in high enough concentrations to harm humans, other organisms, plants, or any of the materials. So where does this air pollution come from? Two main sources: naturally occurring sources and anthropogenic sources. And remember, anthropogenic is a fancy word for man-made. Speaking of man-made, we're talking about burning fossil fuels, right? CO2 emissions, NOx emissions, SOx emissions, carbon monoxide, industry, soil erosion due to mining, soil erosion due to clear cutting, and agriculture. Okay, all of these things humans have a role in. And because of that, we consider them anthropogenic sources. Take a look at our natural sources now. Here we're talking about volcanic eruptions, ash, hydrogen sulfide, SO2 gas, sulfur dioxide in the atmosphere. Pollen is a form of air pollution. Dust from dust storms. Trees and bushes, volatile organic compounds create a blue haze. Forest fires, when you have the naturally burning, right? Lightning strikes a tree, it ignites it on fire, that creates a forest fire. That's not man-made, that's not caused by man, it's naturally occurring. Sea spray, I know you all have seen the videos and pictures, especially now in the winter, of the houses that are covered in ice because of sea spray and the natural decay in swampy areas that lead to methane, the breakdown of any organic matter that leads to methane. So air pollution comes from these two main sources, natural and man-made sources, anthropogenic. So we could break this down a little bit. Again, we've talked about this before, the difference between point and non-point sources. Non-point sources can also be mobile sources. So the point sources are stationary. They're power plants, they're industry, they're factories, they're landfills. They give us out particulate matter, PM right here, SOx, carbon monoxide, NOx gases, hydrocarbons. The mobile sources, those are your non-point sources. Okay, anything that occurs on the road where you have maybe traveling vehicles, anything that's moving, anything that is not stationary. Again, you could still get the same type of pollutants, carbon dioxides, particulate matter, again, hydrocarbons, NOx gases, nitrogen oxides. And then you have other non-point sources like mines, which can lead to soil erosion or acid drainage or acid runoff. Agriculture, feedlots, larger plantations, tree farms, okay? Anything that is releasing particulate matter or gases into the atmosphere. Remember, solids, liquids, or gases. Continuing on, we see here that we have the atmospheric diagram. I know you guys have seen this before. We've gone over this before when we were talking about the atmosphere. We have the troposphere, the stratosphere, the mesosphere, the thermosphere. We keep it going up, but we have a couple very important things that occur, especially the two temperature inversions that occur in the troposphere and in the thermosphere. The thermosphere kind of gives it away because of its name, thermo, right, temperature. But the other one is the troposphere, and we talked about this. Why does it occur in the troposphere, the temperature inversion? And that is because of the ozone layer. The ozone layer traps in that heat, okay? So technically, as you go up in elevation or altitude, it should get colder. But we know from the temperature inversions occurring in the troposphere and the stratosphere and the thermosphere, temperature inversion occurs in the stratosphere, the temperature actually gets warmer. I apologize, guys. I made a mistake. It is not the troposphere. It is the stratosphere. You've probably been yelling at me over and over, telling me that I made a mistake. I did. I apologize. So the stratosphere and the thermosphere, and it actually gets warmer in temperature. And this warmer temperature kind of acts like a cap. And it doesn't allow pollution to move up past this. And it actually keeps it down inside where it will loom in the stratosphere and troposphere. Okay, so these temperature inversions actually help to keep pollution in, almost like the cap on a jar. Okay, it keeps all the stuff inside. Continuing on, we see the atmosphere again. We see the two temperature inversions. We see the differences of the gases there. Give you a minute to look at that. Air quality in the developed world getting better, but getting worse in developing countries. We see the developed countries, the air pollution kind of has like leveled off, but the developing countries, because they're moving through that demographic transition, it is on the rise. They're becoming more industrialized. And with the industrialization, we see more factories, more burning of fossil fuels. Okay, so the developing countries' air pollution is on the rise. It's getting worse. So I know you guys are familiar with lichens, and this is going to explain why a lichen is like a canary. Canaries are birds that often sing. Lichens can warn us of bad air quality because they absorb it as a source of nutrients. Now, not all lichens are created equally. Some lichens thrive in very pristine and clean air, while others thrive in very polluted environments. If we have those lichens that really, really like polluted environments, if they are thriving, if they are growing, if they are multiplying, then we know our air quality isn't that good. On the flip side, if we have lichens that are thriving in very pristine, clean air areas, and they are dying off, we know that, well, they're dying because the air isn't that good, right? It's more polluted. So these are often the canary in the coal mine. They give us a heads up of what's going on. Okay, they're like that early warning, early detection system. Continuing on, some lichen species are sensitive to specific air polluting chemicals. After Chernobyl, more than 70,000 reindeer had to be killed because they ate radioactive lichens. Now, these lichens reproduced in that radioactive area. They thrived in it. However, they were reproducing very quickly because they enjoyed that polluted atmosphere. They enjoyed the polluted air. They thrived in it. Reindeer ate them, thus they became contaminated as well. Because lichens were widespread, long-lived, and anchored in place, they can help track pollution as it continues on. Okay, so very, very, very important to realize. Lichens help to trap pollution. To trace pollution. So let's take a look at the different types of pollutants. We only got a couple slides left in this one, guys. We have primary and secondary. That's not advanced placement. That is air pollution. Primary and secondary air pollution. Primary pollutants would be emitted directly. The nitrous oxides, the carbon oxides, sulfur oxides, the hydrocarbons, particulate matter, chlorine gas, mercury, lead. They are directly emitted from the source. Secondary pollutants are caused from chemical reactions. Okay, chemical reactions that occur in the atmosphere that lead to these pollutants, such as acid rain, such as ground level ozone and photochemical smog. Okay, so primary are direct from the source, secondary result in or result from chemical reactions. So this looks at a little bit of the primary sources, your carbon monoxides, your sulfur dioxides, nitrous oxide, nitrogen dioxide, so on and so on, your hydrocarbons, your suspended particulate matter. This also shows us a source, a point source and a non-point source, or a mobile source. Your secondary pollutants over here are occurring because of reactions in the atmosphere. They are not emitted from source pollution. They are occurring due to reactions in the atmosphere. Okay, very important. Our last one for the day is combustion as a source of pollution. Combustion would produce those secondary pollutants. We have complete combustion and incomplete combustion. Incomplete combustion results in carbon monoxide, particulate matter, and leftover hydrocarbons, which is essentially the fuels. The impurities that result from combustion are mercury and lead, sulfur, those heavy metals, sulfur and nitrogen. And here we see the combustion reaction. Anytime we're combining a hydrogen carbon with oxygen, we get the carbon dioxide energy and H2O, but the carbon dioxide is the pollutant. So this was our little introduction into air pollution. We are going to continue on in the next video, getting into the major pollutants, looking at those one by one. All right, guys, I hope that you have enjoyed this, and I will see you all in the next video. This is Mr. F saying have a great day, and don't breathe in any air pollution. It's not good for you. All right, bye, guys. Take care.